Hey guys! This is going to be a quick video reviewing the stoichiometry that we had done prior to the school shutting down. So I would recommend giving this a run through if you just want to stay sharp on what you're doing. Some of these are examples we've already done in class, and I will be posting a class kick later, which is an app that you can do some practice on that I can actually give you some direct feedback on. So look for instructions on that as well. So welcome to my house. Right? The moles are safe. They made it. They made it. They're quarantined with me. Um, let's go ahead and do some stoichiometry. All right. So before we left, I had basically taught you three things. I had taught you that 1 mole is equal to Avogadro's number, which is 6.02 times 10 to the 23rd. And remember, that's technically like anything. So particles, molecules, what have you. Essentially, that's just a number. And the word mole is just a word that represents a number, 6.02 times 10 to the 23rd. We use this because atoms are so incredibly small. Having such a large number of them is actually a workable, reasonable amount. So that's one thing. The other thing that we learned was molar mass. So the fact that 1 mole is equal to however many grams of a particular substance. We can find these values on the periodic table. So if you want to look even at the cursor behind me, for example, for oxygen, oxygen has a molar mass of 16.00, which means there are 16.00 grams in 1 mole of oxygen. Next door is fluorine. So in 1 mole of fluorine, it weighs 19.00 grams. So all of those values in the periodic tell you how much 1 mole of that atom weighs. And again, when I'm saying 1 mole, I'm saying 6.02 times 10 to the 23rd. The last thing that we learned before we left was a mole ratio. So however many moles equals however many moles. And we get these numbers from the coefficients in an already balanced chemical equation. Oh my goodness. Okay. So we balance a chemical equation, and that's basically the recipe for that equation. So like if you need 2 of these and 1 of these to make 1 of these. And those coefficients then are telling you the ratio of those objects of those compounds or of those formulas within the actual equation. So it's also just a ratio. We call it a mole ratio because again, we use moles in chemistry because atoms are so small. So this is our toolbox. This is what we know. To be perfectly honest, these are going to be the 2 that we're using the most often. Because this one just isn't that practical because that's a huge annoying number. That's what we came up with moles in the first place. So we have scales that can measure in grams. We need ratios if we're going to go between compounds. That's what we've got. So in a typical stoichiometry problem, basically I'm going to give you a value and I'm going to ask you to convert that value to something else. So for example, if you react 2.46 moles of sodium hydroxide, how many grams of calcium hydroxide would you produce? So again, using those conversions that we just reviewed, we can answer any type of question like this. As you know, our first step is always just to take whatever value I give you and put it over 1. So 2.46 moles of NaOH, and we're going to throw that number over 1. Then you're always going to set up your next step, and you're going to take that unit, and you are going to throw it on the bottom. I have a little like model guide down here that you can kind of use to help you while you're practicing these, but I wouldn't rely on these necessarily. Kirby, leave the moles alone. They're new friends. Okay. So we've got moles of sodium hydroxide, and then we are going to want to get grams of calcium hydroxide. So that's going to be the conversion that we're doing from here. So I currently have moles of sodium hydroxide on the bottom, so I'm either going to do mole ratio or I'm going to do molar mass, going from moles to grams. I'm going to do mole ratio because if I go to moles of calcium hydroxide, I am 1 step closer to grams of calcium hydroxide. Now, if you recall, this is the mole ratio, so we get these numbers from the coefficients. So I'm looking at sodium hydroxide and calcium hydroxide. The coefficient in front of sodium hydroxide is a 2, so I'm going to put a 2 down here because I wrote NaOH down here. And then there is a 1 in front of calcium hydroxide, so I'm going to put a 1 in front of the calcium hydroxide here. So this is a 2-to-1 ratio. Continuing my problem, because it was asking for grams of calcium hydroxide and I currently have moles, I'm going to do one additional step, and I'm going to put moles of calcium hydroxide on the bottom, and then I'm going to put grams of calcium hydroxide on the top. So this is molar mass. As a reminder, we're going to get these values from the periodic table. So I could use the periodic table behind me, and I'd look at calcium, which has a molar mass of 40.08. Oxygen is 16.00, and there's 2 of them. Note the parentheses. And then there's 2 hydrogens. Also note the parentheses. When you add these together, you get 74.10. So 74.10 grams in 1 mole. You can double check to make sure that this makes sense. The moles should cancel out. The moles should cancel out. You're left with grams. You wanted grams. So that can always make sure that you actually got the final answer that you are looking for. So then you're going to go ahead and type this throughout your calculator. So we're going to do 2.46 divided by 2 times 74.10. And don't forget your sig figs, right? So this has 3. So my final answer will have 3. So 91.1 grams. That's going to be my final answer. So that's one example for you. Here's another one. If you produced 0.57 grams of calcium hydroxide, how many moles of sodium hydroxide did you use? Again, we're always going to start off the same. So the number I gave you here was 0.57. So 0.57 grams of calcium hydroxide. Throw that over 1. And then you're going to go ahead from there, take that unit and throw it on the bottom. That's always how you're going to start. Remember, I taught you 3 conversions, but really we're only using 2. Molar mass, which is going to go from grams to moles, and mole ratio, which is going to go from moles to moles. When you're doing grams to moles, it's got to be the same compound, because all those values on the periodic table are telling you how many grams are in 1 mole of that particular substance. And then mole ratio is where you can use the coefficients in the equation to go from one compound to the next. So I've got grams. Well, then I'm going to do molar mass, right? That's the only one that's got grams in it. So it's going to be moles, and it's going to be moles of calcium hydroxide. All right. I don't want moles of calcium hydroxide, though. I want moles of sodium hydroxide. So keep going. Set up your next step. Take that unit, throw it on the bottom. So moles of calcium hydroxide is going on the bottom. And then I'm going to put moles of sodium hydroxide on the top. For molar mass, remember you're going to get those values from the periodic table. This is actually the same compound that we did in the last problem. The molar mass of that was 74.10 grams. And remember, that's always equal to 1 mole. So if it's 74.10 grams, I'm going to put 74.10 grams on the bottom and 1 mole on the top. Mole ratio, you get those numbers from the coefficients. It looks like this is another 2-to-1 ratio. 2-to-1 ratio. Make sure you're lining up the compound with the coefficient. So then you're going to go ahead and plug this in. So 0.57 divided by 74.10 times 2 in this case. Check your sig figs, like always. 2 sig figs. Throw my answer down here. 0.015 moles is going to be your final answer because you only want 2 sig figs. All right, I'm going to do one more for you, okay? And then if you want any additional practice after that, you can look at the homework and you can look at the class cake. All right, this is a gram to gram. This is as long and as big and as scary as I get. So if you can do this, you're golden. So if you start with 0.31 grams of barium chloride, how many grams of sodium chloride would you produce? Again, take our number. So 0.31 grams of barium chloride, put it over 1, okay? And then you're going to set up your next step, take that unit, and throw it on the bottom. Okay. Molar mass or molar ratio? I've already got grams, so I might as well do molar mass and go to moles. It's got to be of the same compound, so moles of barium chloride. I don't want moles of barium chloride, though, because it was asking me for grams of sodium chloride. That's not what I want. Keep going. So I'm going to go ahead and throw moles of barium chloride on the bottom. So I just did molar mass. I can do molar mass or molar ratio. So I'm going to go ahead and do mole ratio. because that allows me to go to the next compound. So I can do moles, and then this is where I can do the moles of sodium chloride on the top. That's kind of your bridge between compounds, since I ultimately want to get grams of sodium chloride. But I don't want moles of sodium chloride, I want grams. One final step, moles of sodium chloride on the bottom, grams of sodium chloride on the top. Boom. Here's your setup. After that comes the numbers. If it's grams to moles, that's molar mass. You're going to get those values from the periodic table. So let's go ahead here and just do this one together. So you're going to work with me? Perfect. So we've got barium right here. So barium is 137.34. 137.34. And then it's barium chloride, so it's BaCl2. So then I'm going to do 2 chlorines, 35.45. Make sure that you're actually looking at the type of formula. Sometimes people just do Ba plus Cl instead of Cl2. So just make sure you're careful what the actual formula looks like. So I'm going to go ahead and add these up. So 137.34 plus 35.45 twice. I'm getting 208.24. Remember, that's grams, and that's how many grams 1 mole is equal to. So I'm going to go ahead and plug that in. 208.24 grams in 1 mole. Molar mass, getting that from the equation. So barium chloride is right here, and sodium chloride is here. So 3 to 6. So 3 to 6. Again, I'm lining up the coefficients with the different compounds. You could reduce this down to 2 to 1, or you could just leave it as 6 to 3. It doesn't matter. And then the final molar mass, and this one's going to be of sodium chloride. So again, sodium, my cats are running. Sodium is 22.99. Chlorine is 35.45. So we're going to add those up together. Spoiler, the answer is 58.44 grams in 1 mole. So I'm going to put the 58.44 grams over the 1 mole. Again, that's always the gram value, so you want to make sure you put it with the grams. So we're going to go ahead and plug these in. So 0.31 divided by 208.24 times 6, because it's on the top, divided by 3, because it's on the bottom, times 58.44, because it's on the top. Check my sig figs. 0.31 has 2. Rosie, can you nod? Okay. So I'm going to want 2 sig figs. So my final answer is going to be 0.17 grams. All right, that's everything we did before we left. I'll give you some more materials once school actually is back in session, but if you would like just to review what we've done, there you go. Let me know if you've got any question, guys. I am totally fine to Google Chat, Google Hang, email, whatever you need from me. Stay healthy.